All right, ladies and gentlemen. So we're doing MSM 111 and we are going through, we're revising the test. All right. So we ended on question 2B, we're now on 2C. Okay, now if you look at C was quite straightforward anyway. 2x plus absolute value of x is less than or equal to 6. Right, so 2x plus absolute value of x is less or equal to 6. So in this case, what we need to remember is that this is actually very easy. Okay, but the only problem is that some of you have a tendency of complicating even simple things. Okay, so what do? Remember that the absolute value of x entails that the x value is either positive or negative. So let's look at the first case scenario where it's positive. So 2x plus x is less than or equals to 6. So 3x is less than or equals to 6 over 3 over 3. So x is less or equal to 2. Right, so that is that, right? So that is what you have as your answer. Now next up, what if the x is negative? Alright, so the next scenario we have 2x minus x is less or equal to 6. So we have the first scenario, x is positive, the absolute value part has x being positive, and the next scenario we have the absolute value part x being negative, right? So we have 2x minus x is less than or equal to 6. Right, so now if you look at the two solutions which you have, you realize that these two meet at some point. Okay, so this x is tending towards negative infinity starting from 6, and this one is tending to negative infinity starting from 2. So meaning that this one incorporates this one, right? If I can draw it for you, maybe somewhere here. Okay, maybe just a rough drawing. So we're saying the final answer, the very rough drawing, we're saying we have here we have negative infinity, then we have 6 and we have 2. Okay, so this one is saying you have less or equal to 2, so you're going this way, right? To this side. Then this one here you have from 6 going this way, right? So you see that these two meet at some point, at this point. They meet at this point, right? They meet at that point. So meaning what's the final answer? The final answer for x, since they're both going in the same direction, is x is actually a member of the interval negative infinity up to 2, right? So that is your final answer. X is actually a member of the interval negative infinity up to 2. Okay, so x is a member of the interval negative infinity up to 2. Okay, next question. Alright, the next question says, f of x is given as x plus 1 over x minus 1, right? So it's given as x over x plus. Let the function be defined by f of x is equals to 1 plus x over 1 minus x. If is f a one-to-one function, and so otherwise find its inverse, alright? So is f a one-to-one function, and so otherwise find its inverse. We say the function is said to be one-to-one if f of a is actually equals to f of b, right? Then what you have as f in this case is 1 plus x over 1 minus x. So meaning f of a being equals to f of b, this implies that you have 1 plus a over 1 minus a is equals to 1 plus b over 1 minus b. Okay, if we cross multiply, you have 1 plus a multiplied by 1 minus b. It is equal to 1 minus a multiplied by 1 plus b. Okay, so we have 1 times 1 is 1 minus b. Then a times 1 is a. Then minus ab is equals to 1 plus b minus a minus ab, right? Now we know that when two things are exactly alike but on different sides of the equal sign, then those two actually will cancel out, okay? So since they are like terms but on different sides of the equal sign, they'll cancel out. So what we are saying is that this one and this one will cancel out, right? Then 1 and 1 will cancel out. Because if one followed the other one, it will be 0, right? So negative, we have, let's say the a will come the other side, so we have 2a is equals to 2b over 2 over 2, right? So this concludes that a is actually equals to b. Hence, that's a one-to-one function, okay? In conclusion, we're saying a is actually equals to b, so it's a one-to-one function. Okay. Next up, we've been told to find the inverse of that function. So we say let y be equals to 1 plus x over 1 minus x. Okay, we're looking for the inverse, so we have xy minus xy minus y. Or let's try it like this, over 1 cross multiply, have y minus xy is equals to 1 plus x. Then you're making x the subject of the formula, so you have x plus xy is actually equals to 1 minus y. Okay, it's like this, and this has gone the other side, then the one has followed, so it's actually y minus 1. Okay, so y minus 1. Then we have common denominator is x, so we have 1 plus y is equals to y minus 1 over 1 plus y over 1 plus y. Okay, so what is x? X ends up being y minus 1 over 1 plus y. Y minus 1 over 1 plus y. So this is the inverse, okay? That is the inverse. Let's make it more bold. So I'm saying let y be equals to 1 plus x over 1 minus x over 1 cross multiply, we have y minus xy is equals to 1 plus x. Then we're making x the subject of the formula, so we have xy plus x, okay, is equals to, if the one follows the y, then we have y minus 1. Then we have x, y plus 1 is equals to y minus 1 over y plus 1 over y plus 1. So we have x is equals to y minus 1 over y plus 1 as f inverse. Okay, so that is what f inverse is. So f inverse of x is therefore equal to x minus 1 over x plus 1. Okay, x minus 1 over x plus 1. Which looks like it's just a flip, but it's not automatic. You shouldn't find your flipping number, but because it's the inverse, then you flip it, right? So you don't flip. Okay, so let's look at the next question. Well, now on question 3. Okay, so let alpha and beta be the roots of the equation 2 plus 5x 2 plus 5x minus 3x squared is equal to 0. Okay, so that is what the roots of the equation are. So we have an equation of that sort, and you've been told that the roots of that equation are alpha and beta. Okay, so I usually advise you, so whenever you're given that question, the first thing you should look for is alpha, beta, A, B, C. So A here, from this question, A is actually equals to -3, B is 5, and C is 2. Okay, so it's just been flipped. Okay, if no, not really flipped. The way it's been written is like A is at the far end and C is at the beginning. So take note of such changes, because some of you are so fast in writing that you would actually copy A as 2, B as 5, and C as 3. Okay, so this is 2 plus 5 x minus 3 x squared is equal to 0. Okay, so as I said, take note of such things. They actually are there to capture the one who's too fast, the one who's not analytical, the one who's memorized. Okay, but if you know what you're doing, you shouldn't really have problems with that. You should be able to spot even such tricks that the examiner puts in. Okay, so they are part of the exam. They are part of the exam. Okay, if you fail to see it, it will cost you. So now what we're going to do is we've been asked to find the value. Okay, so before we even do that, we need the sum. So the sum of the roots is found as negative b over a. In this case, we have negative 5 over negative 3, which is just 5 over 3. Okay, and the product of the roots is found as c over a, which is going to be 2 over 3, so which is negative 2 over 3. So that's the sum of the roots, and that's the product of the roots. Now that we have the sum of the roots and the product of the roots, let's find the answer to the question that we've been given. Okay, so according to the question that's been written for us, we've been asked to find alpha over beta squared plus beta over alpha squared, right? So common denominator here is alpha squared, beta squared. So the common denominator is alpha squared, beta squared. And you notice that this is alpha cubed plus beta cubed, right? So that's what you have in your numerator, alpha cubed plus beta cubed. Okay, then from there now, okay, so alpha cubed plus beta cubed over alpha beta, then we have squared, right? So I've just factored out the square on both, because it's one and the same thing, the way I've written it. There's nothing which I've changed. Okay, now this is a general formula, right? So we're saying we have alpha cubed plus beta cubed over alpha squared, alpha beta squared, right? Then from here now, this is the formula, and what it is alpha, let's write it here. This is equal to alpha plus beta cubed minus 3 alpha beta, alpha plus beta, alright? Then over alpha beta squared. But we know the sum of the roots is 5 over 3 cubed minus 3. The product of the roots is negative 2 over 3. Okay, then the sum of the roots is 5 over 3. Okay, so 5 times 5 is 25 times 5, 125. So we have 125 over 9 minus 3 and 3 will cancel, minus 2. 2 times 5 is actually 10, so we have 10 over 3. So basically speaking, it's like we are now saying common denominator is 9. It's 125 minus 30, okay, which is actually going to give you 95 over 9. So that is your final answer, 95 over 9. Okay, so that's what we have as our final answer. Okay, so that's what we have, 95 over 9. And now, note that what we've just written there is just the numerator, okay? We now need to evaluate the denominator as well. What we have there is just the numerator. Okay, so what's the final answer now? So the denominator is basically okay. Now another note, okay. Notice that here you have a negative and here you have a negative. So it's basically supposed to be positive. So that we have, this is 135, 155. Okay, so this is 155 over 9. Okay, so that's 155 over 9. Okay, so we have 155 over 9. Then we are now saying 155 over 9 divided by alpha times beta. From there, we had the product as negative 2 over 3, right? So we have negative 2 over 3 squared. So we have 155 over 9 multiplied by, if I flip this, remember this is 4 over 9, so this is going to be 9 over 4. So this and this, so the answer is 155 over 4. Okay, so that is your final answer, 155 over 4. Next question. Okay, so the equation whose roots are alpha squared and beta squared is in the form, let's see. The equation whose roots are alpha squared and beta squared. Okay, so before we even write that, let's note this. Okay, so we found out the sum of the roots from the equation that we have. The sum of the roots was found as from here 5 over 3. Okay, product of roots was found as negative 2 over 3. Right, so I'm going to use them in order for me to find what we're looking for. Okay, so every quadratic equation can be written as x squared minus sum of roots, x plus product of roots, right? Okay, so we now have x squared. What are the roots in question? We stored alpha squared and beta squared. Okay, so the sum of these roots is alpha squared plus beta squared, right? Then x plus the product of the roots alpha squared multiplied by beta squared. So I'm adding the two roots and I'm also multiplying the two roots. So the product of alpha squared and beta squared will be alpha beta to the power 4. Alright? if you multiply those roots. Okay. So we're saying every quadratic equation can be written as sum of roots x plus product of roots. So the sum of roots is alpha squared plus beta squared for these that have been given. So we are adding them alpha squared plus beta squared x, then we are multiplying the roots. We have the product of the roots is alpha squared times beta squared. Right? So if you want, you can write this as alpha squared beta squared. Okay? Since I'm multiplying the two roots, so that's the actual product of the roots. Okay, so from here now, we know that this is the standard formula for alpha plus beta squared minus 2 alpha beta. Okay, then x, this is the standard formula, and it's written as alpha plus beta squared minus 2 alpha beta. Then this is alpha beta, then we have squared. But we know what the sum of the roots is. So the sum of the roots we found as 5 over 3 squared minus 2. Product of the roots is negative 2 over 3. Okay, x from the quadratic equation which we were given. Right. Then we have plus product of the roots negative 2 over 3 squared. Okay, so from here we have x squared minus, this is 25 over 9 plus 4 over 3 x, then plus 4 over 9. Okay, common denominator there is 3, it's 9, so now we have 9 here. We have 9. Okay, so as I said, common denominator is 9, so we now have this as x squared minus over 9, then 25, we have 25 plus 12, okay, because 3 into 9 is 3 times 4 is 12, then x plus 4 over 9 is equals to 0, it's an equation. So we have x squared minus, then we have 25 plus this is 37 over 9, x plus 4 over 9. So if we want, we can actually get rid of this. Okay, so that we have x squared minus 37 over 9, because this is 37 over 9 times the negative 37 over 9, x plus that is equals to 0, multiply throughout by 9, so that we have the final answer is 9x squared minus 37 x plus 4 is equals to 0. Okay, basically speaking, if you left your answer as this part, I would still mark you correct. Okay, so either that side or that side, the answer is still remaining the same. So let's just say we end your answer here. Okay, so that's your final answer there. So that's the end of that question. Okay, so what we just did here is we made this into a single fraction, but there's a negative outside, that's why we say negative here. The next question says, let hx be the function hx is close to 2x minus x minus 6. Okay, alright, so I'll skip B. Let's do C, part 1 and part 2. Okay, so skipping B, I want to do C, part 1 and part 2. Okay, so maybe B. Hx has been given as 2x squared minus x minus 6. I'll just get back to B first. We've been taught to leave it in the form r x plus s squared plus t. So in short, you've been asked to complete a square. Okay. Doing that, this is going to be, I'm going to factor out 2. Then what remains is x squared minus x over 2, then minus 6. Then from this, I'm going to pick just one x. Half of 1 over 2 is 1 over 4 squared minus negative 1 over 4 squared. Then minus 6. Then we have 2 x minus 1 over 4 squared minus 1 over 16. Okay, minus 6. If I multiply out 2 out by 2, we have 2 x minus 1 over 4 squared minus 1 over 8 minus 6. Right. So making this into a single fraction, common denominator is 8. So we have negative 1 minus 8 times 6 is actually 48. Right. So we have negative 49. So we have 2 x minus 1 over 4 Okay, so basically what I did was this. From here I factored out a 2 from only these two variables. That's what I usually do. Okay, then after that, after factoring out, I pick one x, which is the one I've written here, minus half of the number here. So the sign here is minus, this is why it's half, it's minus, then half of 1 over 2 is 1 over 4, then squared, then minus the same number which is here, squared, so negative 1 over 4 squared, then minus 6, alright? Then from there, I simply say negative 1 over 4 squared is 1 over 16, then we still have this here, then I distributed the 2, 2 times this is this part, then 2 times negative 1 over 16, 2 into 16 is 8. So we have negative 1 over 8. Then minus, now I have opened the 6, alright? So the common denominator between these two is 8, so this becomes negative 49. Okay, so this is what we get. So we're going to have 2x minus 1 over 4 squared minus 49 over 8. Okay, so that is what we have as our final answer. So 2 open brackets x minus 1 over 4 squared minus 49 over 8. Okay, that is what we get as our final answer. Okay. Yeah, so basically speaking, this is our final answer. Then it says, hence determine the turning point. Hence determine the turning point of hx. So we want to determine the turning point of hx, right? Now we know that the turning point from that, turning point is actually the turning point will be given as s comma t. Okay, so in this case, what is the s? Okay, now since we have plus there, it's negative s. Okay, so it's negative s comma t, right? So the turning point is negative s comma t because of the plus x plus s, but if it was x minus s, we would have had the s here being positive, right? So what is s from what we found is actually 1 over 4, comma, what is t? Negative 49 over 8, right? So this is what we get as our turning point. So the turning point is negative 1 over 4, comma, yeah, 1 over 8. Okay. Next, sketch. Okay, so it's sketch the graph of g of x is equals to absolute value of h, showing all the intercepts and turning points. Okay, so we have the turning points. To find the y-intercept. Okay, so y-intercept. We know that for the y-intercept, x is equals to 0, right? So we have h of 0 is actually equals to -6. So this is the y-intercept, right? Then from there we have the next part, which is the x-intercept. So x-intercept, okay, h of x is actually equals to 0. Okay, so since h of x is being equated to 0, so same as saying 2 x minus 1 over 4 squared minus 49 over 8 is equals to 0. Alright, so let's solve for x. So we have 2x minus 1 over 4 squared is actually equals to 49 over 8. Then I'll multiply throughout by 1 over 2 because I want to get rid of the 2 in front there. We have x minus 1 over 4 squared is actually equal to 49 over 16. Okay, take the root there, take the root there. We have x minus 1 over 4 is actually equals to 7 over 4. Okay, it's equals to 7 over 4. Okay, so x minus 4, 1 over 4 is equal to 7 over 4. So now we have plus or minus. So we have x is equal to 1 over 4 plus or minus 7 over 4. Then we have x is equal to 1 over 4 plus 7 over 4, which is 8 over 4, which is 2. Okay, then we have x is equal to 1 minus 7 over 4, 1 over 4 minus 7 over 4, which is actually negative 6 over 4, which is negative 3, which ends up being negative 3 over 2. Okay, so these are the two intercepts. We have x is equals to 2 and we have x is equals to, so x is equals to 2. We have x is equals to 2, we also have x is equals to negative 3 over 2. Okay. And x is equals to negative 3 over 2. Okay, that having been said, we now have all the information we need in order for us to sketch this. So, sketching, okay, I hope my graph will be visible enough. Okay, yeah, it will. Okay, so intercepts, we have negative 3 over 2, we have 2 here, Okay, now, of course, we did not check whether that's a maximum or a minimum. We did not check whether it's a maximum or it's a minimum turning point. Okay, so now we know that from the looks of things, the positive 2 there, the h of x is equal to 2 x squared. The coefficient of x squared is actually positive 2. Okay, since it's positive 2, it entails that since it's positive 2, it actually tells us that that's a minimum turning point, right? So it entails that that's a minimum turning point. So basically speaking, we have a minimum turning point. Now the turning point was found as negative 1 over 4, comma, negative 1 over 4, comma, 49, negative 49 over 8. So it was actually positive 1 over 4, comma, negative 49 over 8. That's what we had as our turning point. Alright, then we have our y-intercept as negative 6. So if you look at negative 49 over 8, okay, so we want to ask ourselves, we know that 8 can go into 49 6 times, remainder 1, so it's actually greater, okay, so meaning if I have this graph here, it's going to turn here, okay, so but it's not the actual graph we're looking at, so let me dot it. I explain why it's dotted later, right? So it's dotted, crosses there, turns. Okay, so what I mean is this point here is negative 6, right? And this point here is negative 49 over 8. Okay, so we have negative 6 and we have negative 49 over 8 is that point. Okay, the reason why we've written it like that is simple. Okay, I want you to actually be able to say the intercept which we have is actually negative 6, right? So the intercept which we have is negative 6. Then from there, what we're going to do now is we want to consider the absolute part. Okay, so this graph I've sketched here, okay, crossing here up to this point is this is the graph we're actually calling f of x. Okay, that's the graph we're calling f of x. That's the graph we're calling f of x. So this graph here is the one we're calling f of x. All right. So it's dotted there. Then this point, as I said, is negative 6. Then this is negative 49 over 8. Okay, so that's negative 49 over 8. Now, what we have f of x, but now we were also told what is hx, the absolute value of hx. Or if we want, actually, we have to write this as hx, okay? Now, the absolute part simply means that whatever is negative is made positive, right? So, the absolute value of the intercept will no longer be at negative 6, but the intercept will now reflect at positive 6, all right? So, we have that. And the turning point will also shift. Instead of being a negative, it will become a positive, right? So, we'll have this... this sort of scenario here where we actually have this point going this way, that point going that way, then we'll have this graph turning from here, okay, it will turn above 6, it will come there. Okay, let me just make the graph look a bit more beautiful than that. Okay, so we're saying this graph here continues. Okay, so this is the part where it continues like that, then it goes like that, it also continues like that. So you can see there's a continuation in that graph. Okay, so there's a continuation here. Yeah, there's a continuation in that graph. Then we've reflected the negative 6 because of the absolute, right? The negative 6 will become positive 6. Okay, so as I said, I really want this thing to look a bit more beautiful. So it will come here, remember it's turning, it's going to cut the, yeah, it's going to cut the y-axis and it turns. Okay, so it's going to cut the y-axis. After cutting, then it turns. Okay, so that it turns a bit higher than. Okay, so yeah, we have something like this. So this is now positive 6, and this is 49 over 8. Positive 49 over 8, right? So this is what you have as your graph. Now this is the y part, that's the x part, right? So now you have to really show. Okay, so usually the absolute function doesn't really affect the x-intercepts, it affects the y, because it affects the results, not the inputs, but the outputs. This is why you usually notice that if you are solving such questions, these two intercepts remain unchanged, but the y-intercept will change. Also, the y value on the turning point will also change. Okay, so if it was, now it's reflecting in the negative, it will now reflect on the positive. All right, so that is that. So this graph here is the one asserting absolute value of x. All right, so that's the absolute value of hx. That's how you solve that question. Okay. All right, so that marks the end of that question. So you can see that I've actually dotted this one because it's not the one we are interested in. Okay, so this one is dotted. Okay, so that one is dotted like that. Then this one is the one which is a bold line. All right, but this remains the same. So if you check, this is still 1/4. Okay, so it's 1/4 on both. Okay, so that is still 1/4. Okay, so we have 1/4 there, we have 1/4 down there. Then these 2 points are the intercepts, so this is 2. This is 2. This line is bold. Okay. So this is actually 49/8. 49/8. Then it's turning at, yeah, it cuts the y-axis at 6, then turns at 49/8 and goes back down. Right, so then it reflects. Because of the absolute, this is why you see that you have the reflection of this at the, it usually always reflects at the x-intercepts. Okay, so it always reflects at the x-intercepts. That is that. Let's go to the next question. Okay, so the next question is saying, if the quadratic equation that has one root twice the other, find the values of k, hence determine its roots for the values of k. Okay. It has one root twice the other. It has one root twice the other. Okay, so whenever you're given such questions, as usual, the first thing that you need to find is the product and the sum. Okay, so we need to identify our A, our B. Okay, so we need to identify A, B, and C. Alright, so from this we have the sum of the roots. We have the sum of the roots as alpha plus beta is actually negative 3k over 2, and the product of the roots c over a, which is 5k over 2. Okay, so we have the sum of the roots and we have the product of the roots. Okay, then from what we get, we have alpha plus beta 3k over 2, and alpha times beta is equals to 5k over 2. So now we've been told that this has got one root twice the other. So we've got one root twice the other. It has one root twice the other. So if your first root is alpha, then the other root will be 2 alpha. Okay, that's one root twice the other. If the one root is alpha, then the other root will be 2 alpha, right? So meaning you have the sum of the roots as, so we're saying if you have one root as alpha, then the other root will be 2 alpha, right? Then you have the sum of the roots as alpha plus 2 alpha, and this should give us 3k over 2. So you have 3 alpha is equal to 3k over 2. Okay, so if you want, you can get rid of the 3. Okay, so you can get rid of the 3 by multiplying by 1 over 3. If you do that, then you have, this implies that alpha is now equal to k over 2. Okay, so this is what your alpha is. Then from there you can also find the product of the roots. So it's alpha times 2 alpha is equals to the product of the roots, which we have been given is 5k over 2. So we have 2 alpha squared is equals to 5k over 2. But we can actually also get rid of the 2 even from this other side by multiplying both sides by so that's your equation 1 by 1 over 2. Okay, then we have alpha squared is equals to 5k over 2. Right, now what we want is, we now want to solve for k because that's what we've been asked for, but we know that alpha is given as k over 2, so we can replace where there's alpha here with k over 2 squared is equals to this will be equal to 5k over 2. Then we have k squared over 4 is equals to 5k over 2, right? Then since we are solving for k, I can cross multiply. This implies that we have 2k squared is equals to 10k. Okay, if the 10k goes the other side, you have 10k squared minus 10k is actually equals to 0. Alright, then I'm now writing here, right? So we have 2k is common, so I can factor out 2k. What remains inside is k minus 5 is equals to 0. So k is equal to 0. We can say 2k is equals to 0. Then we have over 2, so k is 0. And we have k minus 5 is equals to 0, so k is actually equals to 5. Okay, so we have those two values as the values of k. So k is 0 and k is equal to 5. Okay, now that we know what k is, Now that we know what K is, let's consider what the other part of the question says. Okay. So it says determine its roots for the values of K. Okay, so what we're looking for basically is we're not ending at K, we want to know what the roots are. Okay, so for when K is 0, what happens to these two? Okay, when K is 0, well, where's that alpha one? Okay, so I'll use the one which we have for alpha. It's equals to K over 2. Okay? So we know that alpha is equals to K over 2, right? Let's find it here. Oops. We know that alpha is equals to K over 2. So when K is equals to 0, alpha is actually 0 over 2, and this is 0. Okay, so please do not master, read the question. Some of you might have been ending at K. When the question says determine the roots for which K is this. So find K, then determine its roots. It goes further than that. Okay. Then we have alpha is equals to 5 over 2. Okay. For K being equals to 5. Right. So for K being equals to 5, we have that. So we're saying alpha is equals to K over 2. So for K being equals to 0, then we have alpha is equals to 0 over 2, and this is also 0. Then for K being equals to 5, then alpha is equals to 5 over 2. Alright, so those are the roots that we have. So that's the answer to that question. That is the answer to that question. Do not master these things. Read the question carefully, then do what the question asks you. Just because you saw a similar question in the tutorial, you saw a similar question in quiz 1, then you just assume you plug in. Okay, you don't plug in directly. Read the question. There might be changes that are there. The question may be asking you something different. Of course, you remember maybe in the tutorial sheet there was a question that was saying has roots, one root twice the other, but maybe there you are being asked to determine the resultant equation after you find K. But now here you are being told find the roots after you find K. Okay, so you get it wrong at the final end because you are now finding the equation when the question has asked you to find the roots. Okay. Lastly, okay, so due to time, it would be very difficult to do this question, but here is the pointer. Okay, so I'll give you pointers. It says 240 meters of fencing. So we have 240 meters of fencing, right? It's available to enclose a rectangular playground. So this playground is a rectangle. Okay, so what's perimeter for a rectangle? It's 2L plus 2B. For you people who are visually oriented, so this we have length B, L, right? So if you add, perimeter is the total area, it's the sum of the total size of a given object. Okay, so the perimeter, we have the sum of all the sides around a given object. Okay, so in this case we have 2 L's and 2 B's, so that's perimeter. Then you've been told that we have 240 meters of this to enclose 2L plus 2B. Okay, so if you divide throughout by 2, you have 120 meters is equal to L plus B. All right. Then what is the area that is given? So the question now is saying, if the total enclosed area is 3,600 square meters, what should be the dimensions of the playgrounds to maximize the area? So you've been told that if the total enclosed area is 3600 square meters, so meaning area, we know area is L times B, right? Then what you've been given is 3600, and this is LB, right? Now you have been asked what do we need as the total. So this is equation 1, equation 2, right? So you're going to solve those two simultaneously to get the answer. Alright, so you have equation 1 and you have equation 2, solve them simultaneously. So you can make one of these the subject of the formula from one of them. Okay, let's say maybe we make B the subject, so we have B is equals to 120 minus L. Then replacing that, we have 3600 is equals to L. We've replaced B with 120 minus L, so we have 3600 is equals to 120 L minus L squared. So we have L squared minus 120, L is plus 3600, 3600 is equals to 0, right? So this is now a quadratic equation, as you can see. So find the maximum turning point for this quadratic equation, and that's how you get to your answer. So if I'm going to use okay, so let's say we use, in my case, what do I want to use? Okay, so I'm going to use completing the square. Okay, so I'm going to use completing the square. This is going to be L minus 120. Okay, so half of 120 is 60. Okay, so squared, then plus 3600. Okay, actually minus 60 squared. So I've picked one L, then minus half of this is 60, then squared minus 60 squared, then plus 3600 is equals to 0. Then we have L minus 60 squared minus 3600 plus 3600 is equals to 0. This and this will cancel, so L minus 60 squared is equals to 0. Alright, so in this case, what you need to know is what we have is this one is the value, okay, for the turning point. So the turning point is actually at 60,0, right? So the total length, so our L should be 60, meaning that our B will also be 60. Right, so you need 60 meters for both. So B will be found as 120 minus 60, which is 60, right? So 60 meters and 60 meters. That's how you find that. Right, so that having been said, this marks the end of this tutorial. Have a good day.